Hello everyone, welcome back to CBSE Secrets of Science. Have you ever wondered how a mirror shows your image? What's the science behind it? To understand that, we first need to understand light and reflection. So in this video, let's learn these concepts in a simple and interesting way. Let's get started. What is light? Light is a form of energy that enables us to see objects around us. It travels in straight lines called light rays. Did you know light rays at an incredible speed of 3 into 10 power 8 meters per second in a vacuum? That's about 3 lakh kilometers every second. Now here's an interesting question. If light always travels in a straight line, then how does it return from a mirror and reach our eyes? Let's find out. Reflection. When a ray of light strikes a smooth surface like a mirror, it bounces back into the same medium. This bouncing back of light is called reflection. Without reflection, mirrors would never form images and we wouldn't be able to see ourselves. But how do scientists represent this process? They use something called a ray diagram. A ray diagram helps us understand exactly how light travels and reflects. It contains 6 important parts: incident ray, reflected ray, normal, mirror or boundary, angle of incidence, angle of reflection. Let's understand each one. Incident ray. The incident ray is the light ray traveling towards the mirror. Think of it as a cricket ball moving towards a wall. The moment it reaches the mirror, something interesting happens. After striking the mirror, the light bounces back. This outgoing ray is called the reflected ray. Notice that it leaves the mirror in a different direction, but according to a very special rule. Normal and angles. Before measuring the angles, we draw an imaginary line exactly at 90 degrees to the mirror. This line is called the normal. The angle between the incident ray and the normal is called the angle of incidence, represented by I. The angle between the reflected ray and the normal is called the angle of reflection, represented by R. Remember this carefully because students often confuse the normal with the mirror itself. Law of reflection. Now comes the most important rule. The angle of incidence is always equal to the angle of reflection. In simple words, I is equals to R. If the incident angle is 45 degrees, then the reflected angle is also 45 degrees. This simple law is followed by every plane mirror. Types of reflection. Does every surface reflect light in the same way? No. A smooth mirror gives regular or specular reflection where the reflected rays remain parallel. A rough surface gives diffuse reflection where the reflected rays scatter in different directions. That's why you can see a clear image in a mirror but not on a rough wall. A plane mirror has a flat surface. It forms an image that is virtual, erect, same size as the object, laterally inverted means the left and right sides are reversed. This is exactly what we observe every day when we look into the mirror. Do you know science behind the mirror? Now let's understand the complete process. Light first falls on an object. The object reflects that light. The reflected light reaches the mirror. The mirror reflects it again towards our eyes. Finally, our brain traces these rays backward, making the image appear behind the mirror. That is why the image looks as if it is inside the mirror, even though no light is actually coming from behind it. A real image is formed when light rays actually meet. Such an image can be projected onto a screen. It is actually inverted. A convex lens and a concave mirror can produce real images under suitable conditions. Convex mirror. A convex mirror curves outward. It always forms a virtual, erect and diminished image. Since it gives a wider field of view, it is commonly used in vehicle rear view mirrors and security mirrors. Uses of convex mirrors. Think about the side mirror of a car. It helps the driver see a much larger area behind the vehicle. Similarly, convex mirrors are used in shops and at road intersections to reduce blind spots. Concave mirror. A concave mirror curves inward. Unlike a convex mirror, it can produce both real and virtual images depending on where the object is placed. It can also magnify objects. So, concave mirrors are used by dentists to examine teeth. They are also used in makeup mirrors and torches because they can focus light into a powerful beam. That's all for today's video. In the next video, we will learn more about ray diagrams and their uses in the real life. If you found this video helpful, don't forget to like, share and subscribe to CBSE Secrets of Science. Thank you for watching and I'll see you in the next video.